this is very challenging because we have a presentation about AI and the futures and the technology, very entertained. Now we have we had a presentation about the BT Tower and all this history and see a lot of what happened in the past. Very, very interesting. And now you are with me talking about bidding policies, which probably is not the most exciting topic. But well, I'll try to do my best. At least it's not the session after the lunch when everybody's kind of sleepy. So thank you very much for the previous presentation. So you're kind of awake. My name is Arturo Servin. I'm a technical project manager at Google. I'm part of the global team that we manage all the interconnections for Google and also for a big part of Alphabet, that is the main company above us. And yeah, we set up the bidding policy how we are going to interconnect, or how we interconnect with networks to Google network. This is my first time in a LINX meeting, so thank you very much for having me here. I'm not unfamiliar with the UK. I came to live here in the 2005. Then I went to South America in 2010, then to California. But my family came back to the UK, so I've been commuting from California to London. Where I did that for a few years. Then I moved to Zurich. I still do that commuting, but I'm kind of like London and LINX because many things that are close to my heart. So I'm very happy to be here. So I'm going to talk about these new Google policies for bidding and why we change this. This is a little bit of the how we are going to cover. We want to be very transparent of what we do. We know that we are a big network. We know that we are kind of important in the internet, and I don't want to say it with arrogance or trying to patronizing. But if we do something wrong, if we get it incorrectly, we are going to affect somebody. And we see it when we have like problems in the networks. Anything might happen. So we are very conscious that anything that we do is going to be affecting somebody. So we took this change in the Google policy very seriously. We discussed it for a long time. What was the best way to do this? So this presentation is part of explaining a little bit what we are doing and why we are doing that. Most probably you won't agree with some of the things that we are doing it. And we completely understand that. Probably some of you are going to say, well, this is bad and you shouldn't do that. We know it, but we want to explain why we are doing it. One of the main reasons that we are changing this policy is because we want to be more reliable. I'm going to talk a little bit more about how the network evolved and the services that are in Google network. But in the past, if the bidding fails, it's like, well, yeah, you cannot search. Search is important, but you can survive. You maybe can go directly to Wikipedia or someplace else, and then you get your answers. Your cat videos, well, you cannot see cat videos. Yeah, I can do something else. But today, if the Google network fails, we're not just affecting the cat videos and the search. We are affecting a lot of companies that are behind Google buying the cloud computing services. So today we have a big responsibility with our customer, with you. Like many people of you have Gmail, not as the free version of Gmail, as part of a paid product that you are paying Google to have. Same as Google Drive, same as many virtual machines that are there that they rely that the Google network is working. If something fails, we have like a big problem because you are not selling or you are not buying, and then you are losing money. So it's not anymore about Google just losing money because every time that the network went down, we couldn't sell ads, so we lost money, but it was Google money or Google loss of that. Today is you are losing that as well as a customer. So that is why we are doing all these changes. I'm going to talk a little bit about the Google network. So the Google network, I don't know if you remember Shrek. And Shrek said that ogres were like onions because they were in layers. So, well, Google Network also is like onions because we are in layers. So in the core of the network, we have the data center. So we have massive data centers around the world. We don't have like many of those. We have just a few of them that are very large. And they are in specific parts of the world. And then we have what we call mini clusters that are like small data centers that we use for cloud and expand much faster than building this large data center that they take a few years to build. So this mini cluster, there are anything but mini because there are around like some tens of megawatts. So there are like not mini by itself, but we call it mini because compared with the other ones, they are relatively small. So that is the data center layer. Then we have like the edge POPs. We have around, I don't know, like 100 POPs around the world in 70 countries, something like that, that they connect Google Network with the external world. Basically, all your ISPs, Internet Exchange Point, they are connected to that layer. And in the edge, we have what we call the Google Global Cache. We have several thousands. I was telling somebody that we have more caches in countries that are recognized by the United Nations. I think like United Nations recognizes 196 countries, and we have caches in 200 and something countries. So it's a very large network. It's a very robust and also very mature network. That is part of the problem that we have now, that we have a very mature network that is very expensive to expand and to build extra hubs of interconnectivity to that. And in the middle, we have the backbone. Today, we have 3 backbones. So we have like the backbone that connects the data centers between them. Also, we have the backbone that connects the edge POPs between edge POPs and to the data centers. And we have a new network that is called AlphaNet that basically is going to replace the other 2. So we are going to have like one network in the future. But that is the other layer of connectivity that we have. This is how the technology evolved, and also how we later we are going to link this to how we evolve the bidding policy. So we have the desktop world. So in the 2000s, almost 20 years ago, it's like when you say it, it's like, wow, yeah, we are kind of, well, I am kind of old. So basically in that time, it was desktop. And also it was the first days of the video on demand. So YouTube started like getting there. So with search, with a desktop, what we needed, it was a low latency network. So we started like building some of the first submarine cables with the partnerships, building POPs outside the United States. So we started building POPs in APAC, South America, and Europe, basically to reduce the latency for ads. And later, during that period, also came the Google Global Cache. Why? Because we have YouTube, and YouTube was growing massively, and we needed to deliver those videos as close and as cheaper as possible to the ISPs. So it was the first part of the growth. We extended the work around the world. The next one, it was the mobile world with the iPhone. All this big growth, because now the video was not only in the desktop, it was also going in the mobile phones. And as we saw, that also starved IPv4. So that's like all the IPs, they went, we ran out of IPs. And also because we have a lot of growth in traffic, we start like adding more capacity. And in those 2 areas, in the desktop, basically we have an open pinning policy. Why? Because we were growing very quickly, and we need to interconnect as much as possible, as fast as possible, and in as cheap as possible as well, because that was another of the reasons that we do it. So during the mobile world, basically we expand the AS15169 to almost everywhere with very low latency. And then it came the cloud, and I will talk a little. I put it cloud and AI edge, but first came the cloud. During this time, also YouTube, like, okay, like we also got other companies like Netflix, Meta, Amazon, Apple, also they came with their own services. So like the growth, it was a little bit less. And then the growth was start being driven by a Google Cloud. So during the last few years, we haven't had any new POP unless there is a big cloud customer and we need to deploy some edge infrastructure to connect to the cloud customers and to the cloud edge. And also, it's important to say that in some cases, there is no YouTube there. It's only search and cloud. Why? Because YouTube is so big, and also they have to pay the bill basically for the network, and they say, well, we don't need to be in this extra country because we have a lot of GGCs there, and the latency reduction is very small. So the cost, the incremental cost for these low benefits is very low. So basically, it's only cloud, and this has been the driver during the last few years. So if you see that we are building another POP in whatever country, most probably it's only for cloud. Also, the AI is coming. The AI is not affecting very much the edge, because if you see the latency, it has been very reduced by the edge infrastructure that we have with search. So the latency in the AI is not how fast is going to be the packets coming from you from the edge point and to your computer. It's going to be like the processing that is in the machine learning or in all this infrastructure, taking your prompt and figuring out what you want and then replying to you. So that is the delay. So the delay for latency is not much, and also the capacity, the packets, the traffic that we are generating with these applications, that is not very different than the traffic that we have from search. So also we're not adding more capacity because we don't need that. So that is the drivers in technology and how they were shaping the changes in the peering policy. So this is a little bit of a close-up of the Google network. So basically, as I said, we have the data centers, we have the backbone, we have the other Google backbone. Now it's going to be a single one. We have the edge POPs. We have all the front-end services that basically receive your query to google.com, your query to YouTube, and then decide that you need to go to a global cache and then receive the video. Also the queries to the DNS, access to the virtual machines in the Google Cloud. All that is done in the edge POP. And then we have the ISPs, where they interconnect with Google using peering. It could be a PNI, or it could be like a public peering with using an internet exchange point. Basically, we have also the Google Global Cache that they receive, or they transmit the big chunk of data for mostly video, but also they serve Google Maps and some other static content. They only have content that is cacheable, and also only content that is not private. Any private, I don't know, Google file, photos that you have, there are in the data center and the edge POPs. They are never put in this infrastructure. And the changes basically is there in the peering, in how we are interconnected network outside Google. This is a very important graph, and it shows why we are changing this policy that we have since long time, and we will put 2015, but that open policy has been like for very, very, very long time. So that open peering policy, as I said, the primary driver, it was to connect YouTube, search, reduce latency during a time of a very high growth of YouTube. From 2018, 2020, YouTube is still growing, but the growth is stable. It's not like this exponential growth that we have in the past. But cloud has been growing. This is just the percentage of growth. This is not like numbers, or like, it's like the traffic for Google Cloud is much less than the traffic for YouTube. It just is the growth that we have, is that the traffic for cloud is growing very fast, and a much higher rate that we have the traffic for YouTube. And as I said, the traffic for search and the traffic for YouTube, if something happened in the network, it's a Google loss. And also it will be maybe your videos, you won't be able to watch it. But if the failure is for cloud, then we are affecting you as well and affecting your business. So we are taking that reliability very, very seriously because all of this Google traffic growth in cloud, we start having some problems with the size of the interfaces. With the size of the interfaces, mostly technological change, that 10 gig is going out. So it's being replaced by 100 gig or 400 gigs. But also we saw a lot of reliability in internet change points. For us, and it's hard to say it here because this is your meeting for LINX, that is an internet change point. But for us, internet change point, they were very unreliable, and they're still very unreliable. And that forced us to do some changes that I'm going to talk about, route servers, for example, but also push us to stop doing IX impeding. So today, if you go and ask Google to pid in LINX, we are going to say no. So we are not leaving IXs. Well, we are leaving some of the IXs. LINX, we don't have any plan for now. But we are not accepting any more connections. So if somebody comes to LINX and Google say, oh, Google is there, they are going to request a bilateral session with us, and we are going to say no. And I'm going to explain why. And that was the big change, I think, that we have in the peering policy. Also, another change, also important one, is like a philosophical one, but also practical one, is that we move from an open peering policy to a selective peering policy. So we are not anymore an open peering policy. We are now a selective. We are not restricted, but we are selective now. As long as you do a PNI, as long as you have more 10 gig of traffic with Google, and you peer with us in one of our locations, or you are in one of our locations, we will peer with you. So that is like, we are still open, but we are a little bit more selective in where we peer, because IXS is not anymore a way to peer with Google, and the speed of the interfaces. If you have 2 gigs of traffic and want to use a 10 gig, we are going to say no. Even if you want to use a 100 gig interface, we are going to say no. Why? I'm going to explain in a moment why. This is what we saw normally in internet change points is that this is a shared fabric. So you don't have control of what you receive. You can control what you send. So we were very good at manage how much traffic we send in an internet change point and not congesting the interface. But the inbound is that even if you don't have a BGP session with somebody says, oh, Google is there, they can jam your port. Normally, we have this with cloud customers that they were there and they were doing like a big transfer of information. They will affect in all the port in the internet change point. And this is what's one of the triggers, because it's very hard to maintain. It was causing a lot of problems with cloud customers because basically it was affecting the whole fabric. Why is a big problem? I was telling somebody that traffic in internet change points for Google is 1-digit%. And it's not even in the high 1-digit%. It's in the lowest percentage of traffic. So it's very small. But the 80% or 75%, something like that, of peers are in internet exchange points. So basically, we have to manage a lot of peers for very little traffic, and they were causing these kind of problems that they were going to knock. Sometimes the knock, as you probably know, our knock is not the best one. So it was difficult to get to this, to the right people. It was causing a lot of problems with cloud customers. So it was this was not the last drop, but this was one of the problems that we were start seeing, like controlling the traffic in internet change point is not impossible. I don't say that it's impossible. It's possible to do it, but it takes engineering resources. And for the amount of traffic that we were seeing, for us, it was very expensive to do that. The other point, probably you already know, route servers. we decommission route servers. Basically, we still have these sessions with the route servers, but we don't announce any prefixes. It was kind of the same problem in the inbound, that somebody discovered the route server, oh, Google is there, and boom, all the traffic, it was there. Also, it was very difficult to control because there are mechanisms. There is the BGP communities that you can use with route server and say, they don't announce these routes to these peers. The problem with that is that there is not a specific standard. The IXs in Europe, they use specific communities, but the ones in South America, they use different ones. The one in the United States, they use another one. So it was another engineering problem for very low traffic. This was the traffic using route server, it was less than 1%, I think. It was very, very, very small. So it was very difficult to control the route server and to do the engineering. It wasn't impossible. I don't want to say that it was impossible, because it's a problem that if you apply the right engineering, maybe you can solve it. But it was costly to solve. It was a lot of moving parts that we need to fix for so little amount of traffic that basically we decide, let's decommission the route server. So we start draining the route servers last year, well, a couple of years ago. And it was the right decision. It's like today we have very little problems in the IXs because of this kind of issues with the route servers. Now we have a peer that is like jamming like the inbound interface. Maybe we can do some TE policies specifically for that peer. So with route server, that was kind of difficult, and that's why we remove it. And I think it was the right decision to do that. Also, this is not specifically for internet exchange points. This is mostly with cloud customers that are connected to us. That I'm going to go to that with something that we call the verified peering partner, and why we implemented that. That program was mostly because of this. So cloud customers, they are not ISPs. So BGP sometimes is kind of a difficult things for them, and they can do problems because they don't sign the ROAS, they do crazy stuff, they have firewalls. So suddenly they have a connection that it goes to the IX or to the PNI. That fails, it goes to another place, but they have a firewall in between. So you have this asymmetric path, and the firewall says, no, this came from another one. Yeah, I'm not accepting, and it broke. So this was more specifically for cloud customers, not dependent for IXs. This is not an IX issue. It's an issue with IXs because cloud customers, because they are kind of small, normally they don't have like a lot of traffic to send or to receive. They normally go to an IX. So we saw them normally in IXs, but it's not specifically a problem with IXs. So that's another problem that we have, is like we have so many peers, and many of those, not you, because I think that you are the ones that they know how the network works and they know how to do BGP. But many of our peers that we have, they don't know, and they cause a lot of issues. And then that's why we want to reduce, or part of the plan is to reduce the number of peers that we have, only to have like big ones connected to us. That brings other problems that I know that you are thinking right now precisely, but is the way that we are trying to optimize the network to be a little bit more efficient operatively. This is a summary of the changes that we had in the peering policy. Between 21 and 22, we start doing a BGP filtering using Internet Routing Registry. All technology, yes, but they have ASets that doesn't exist. Well, it exists now in RPKI, but still it's going to take time for us to cough. But that was the best technology that we had, or we still have, to filter and to reduce hijacks and to reduce routing leaks. So we start doing that in 2021 and 2022. Also, we implement the verified peering, provider called BPP. It was by invitation only during that time. That basically is a peer. I'm going to give you a little bit of the details because this is not commercial, so I don't want to go into much details. But basically, it's a peering partner that we know that they peer with redundancy in the same metro. They are connected to different POPs in the same metro. So we know that if we have to do a maintenance of a router, traffic is going to flow in the other one. Also, they can be connected to different metros. So if we know that if we lost a metro, I think Budapest or Sofia, like 2 months ago, and it was a big mess over there. I don't know if you heard the news, but over there it was a big mess. But if the provider that they have connectivity in Frankfurt and Amsterdam, well, that was like something that we could send the paths using those alternative, we can send the traffic using those alternative paths. So that is the BPP that we introduced. I'm going to talk a little bit more in a moment. 2023, a little bit of a stability and control. Is like we start asking peers to have redundant PNIs, because if they were connected only to one router, we have to do maintenance. Yeah, that connection was off. If they were a cloud provider, probably they didn't have like the proper configuration, and they will shoot themselves in the foot, and it will be a black hole. We have big networks, retailers, that they have like static routes. So like basically when we lose a link, they lost all the connectivity, even though that they have another connectivity or an alternate path in another place, because they have statics and some other things. 2024, basically, we are trying to reduce the technological debt that we have, and then we start doing RPKI filtering. So we started RPKI origin validation. I think like by now, 98% of the peers are filtered with origin validation. And also we start exiting remote IXs. So every IX that it was not in a place where we have a POP, we start cutting those waves. And in 2025 is when we launch this new policy where we are selective, and also we exit some IXs, and we stop peering in IXs. So we don't peer in IXs anymore since I think like a few months. Why? For all those reasons that I gave, that it has been very operative. The operative load that we have with IXs is very high, and it's not longer sustainable for us. So what are we proposing? Because, well, like we are living IXs, so we don't care. Bye-bye, that is your problem. So we are trying to do something that it could be in between. So this is, in the top is the regular model, layer 2, fabric, that is everybody's connected using a switch, and you have bilateral, so you have a route server. In this case, well, you have bilaterals. What we are proposing IXs to have is a layer 3 model, and probably you will say, what the heck, a layer 3, that is like that is 2000 or 90s technology. Yes, it is. Routers that are cheaper now and they are more powerful than like 20 years ago. But the idea here is that we don't have to have all those BGP sessions. We don't want to deal with thousands of peers, that some of those, they will go to a NOC and they will have like a very bad service. We prefer that they go to somebody else that they really know how to treat customers, and divide that. So instead of having like several sessions, we have one session with one ASN, and that ASN connect to us. And how we connect to us? Well, we are proposing PNIs. So basically, it's like the internet exchange point behaves in that moment as an ISP. Think about it tonight and tomorrow, because it took some time for me to think the first time that I heard this from one of my colleagues. Eventually, it makes sense. Okay, it makes sense. Also, it removes this cat and mouse game that we normally have with IXs. When a peer start growing, it's like, hey, can you move to the PNI? And then the IX lose a customer, basically. So with this one, we don't have any incentive to take your customers there, because we don't want more small PNIs. We want big PNIs with just a few networks, and the IXs could be one of those networks. So instead of having like several PNIs or several BGP sessions, we will have like big chunks pipes working with one ASN. And that will be, for us, it will be like a much better a much better scenario than the scenario that we had in the past where everybody was bidding with us. Is this the best for IXs? No, it's not the best for IXs. Definitely it's gonna be disruptive, it's gonna cause problems, it's gonna cost money, and you are gonna hate us. I totally agree. But also it's not the best for Google. So for Google, the best is like, okay, bye, I have all these other paths to send traffic, so I can use these other big pipes, or I can pay a third party, basically a transit provider, to send that, because the cost that we have for transit is very low. So it's like, yeah, that's better. It's like a few tens of bilateral sessions with transit providers that we pay, that's fine. That's better than thousands, several thousand of BGP sessions. And it's not the BGP session itself, because you can say, oh, well, you can have the route server and you will have less than that. Yes, but the route server is like, in the end, it's like you have that relation with the peer. Even if the route server is in the middle, there is like a one-to-one relation of peering there, even if there is a route server. That we don't want to have that relation. So this is not the best for you as an IX. It's not the best for Google as well. But I think, honestly, I think that is the best kind of the things in the middle. So, which probably is a good negotiation. So one of the things that we think about negotiations is that if you are not happy and I'm not happy, but we are kind of happy, yeah, maybe is that okay. Are you kind of happy with that? I don't know. We are kind of happy with that. Hopefully, I really hope that is going to be a solution, and this is something that we can do, because honestly, at least for me, I'm concerned about the small networks that now they cannot use IXs to connect to Google. How we can do that? We can do it with that scenario. That's the only way that I see it, because the other way that I see it is basically Google exceeding the IXs, and yeah, let's use these other paths. So this is what we are kind of proposing IXs. Some of you might have heard this from your community, from some other people, but we were thinking that it was important to start sharing this a little bit more. And why? It's not just because we want it, it's because we want to be, at least us, we want to be more operative efficient, and having all those sessions with everybody, it wasn't something that it was going that direction. So this is basically what I said in the presentation. All the routes are announced between Google and the IX. It's like the IX becomes like a regular ISP. Instead of having eyeballs, they have networks that are connected there. So now the new eyeballs are the networks that are connected to the IX. So it's kind of the same thing. Philosophically, it's an interconnection point. So you are interconnecting. Layer 2, layer 3, we don't care. It's an interconnection. So we have to break sometimes of those philosophical paradigms, layer 2, layer 3, direct or indirect. You are interconnecting and you're receiving traffic in an efficient way, in a business and a technical, relatively efficient way. So we have to start thinking that mental model. And what we do is like we have direct peering, we add capacity as much as we need it. You sell a product, you sell an interconnection, and Google gives you the traffic. So that's very similar to the relation that we have today with very large networks. So that will be possibly a scenario of IXs. I was saying to some people that IXs, you are in a very important moment because there are technological changes. And I think this is a change, and this goes back to what I was saying, that at Google, we do good things and we affect people. And this was one that we really thought about it. And this is one of the challenges that you have as an internet change point. And you don't want to be like the old telephone boxes. We don't want IXs to be like those boxes now being like sofas and chairs there. So we want IXs to survive these kind of changes. So this could be like a way to do it. As I said, this is all the reasons that why we are doing this. Is this simplifies for us the operation, so we can justify staying in IXs. all the aggregating traffic is behind an ASN and BGP session, so it's like simpler for us. Also, it creates new products for all those networks doing that. We see some IXs that they have adopted this model, and they are growing. You were mentioned that traffic is kind of like the growth is very, very stable. We saw some IXs having that, moving to this new model, and traffic just grow like very, very, not exponential, but grow very, very fast. And I think that this model works in that sense. And also, it can improve the experience because you don't have to deal with Google Knock anymore because we know how difficult it is. And with IXs, it's more difficult, like doing that traffic engineering. So I think that it will be better for customer satisfaction. And this is just the bidding, the verified bidding provider, the BPP. I don't want to go too deep in this. I don't want to be kind of a commercial on it. But basically, it's a program where we certify to mostly cloud customers what are the ISPs that they can connect with and have some reliability with Google. Why? Because those networks, the BPPs, they peer with Google in different POPs in the same metro. They might have, if they are gold, they are going to have interconnection in different metros, so that improves the reliability. And also interfaces, they will be like not congested, I think like 50% utilization. And there are some other things there, like there is support, there is knock to knock. And today we have the regular verify partner that is silver, and also we have the gold. Eventually the BPP is going to be BPP, and we are going to have gold, and probably we are going to have a premium one or platinum one or diamond. So I don't know how we are going to name it, but we are going to do some more requirements. For example, we are thinking about adding RPKI origin validation to this. So you as a network will need to become BPP Platinum. Probably you will need to have RPKI origin validation. So we know that you won't be generating hijacks, and then you will be and you are protecting your network. So this is the BPP. And to conclude, what is the next step and what is going to happen? So basically, the growth of Google Network is Google Cloud driven. So if there is no cloud customers, there is not going to be any POP. See, unless there is a big requirement of cloud to build a data center in a new location, we are going to put an edge, and that edge most probably is going to be only cloud. It's not going to have YouTube. Probably it's going to have search, most probably, but YouTube most probably is not going to be there. So now the growth is not by the traffic that we have in the network or reducing latency, not even for AI. It's just for the requirements that we have for Google Cloud. Also in Google Cloud, we see more and more networks or customers connected to the cloud, to the private cloud, so not going to the public internet, just connecting directly to Google in a private connections because they can use like private IPs, and there are some other advantages that they might see in those networks. So that's the cloud the expansion is basically driven by Google Cloud. Also, we are going to put the focus in BPP, trying to certify as much network as possible, and also evolving the program. And finally, the impact of AI. We don't know what is going to happen. It's like what it was told during the morning. We don't know. Maybe we are in a bubble, maybe not. Maybe just the tip of the iceberg. Most of the effort in Google in building infrastructure is in AI. So we are building data centers AI-centric, not anymore like with the normal CPU. Those ones, they are with GPUs and TPUs. That is the other architecture that we have to do the processing of AI. The edge, I think, is not going to be affected because, as I said, the delay, the latency is not in the response to the query, it's processing the query itself. So I don't think that AI is going to have an effect that is going to push us to install more infrastructure in the edge. And yeah, that's all. Hopefully these were not so sad news and horrible message from Google, but we have to do it. It's like there are news that they are not good, and some strategies that probably we are not in agreement, but we have to talk about them, and we have to tell people about them, and we have to be honest about that. And it's something that push us to do this presentation. This is similar to another presentation that we did in NANOC in the beginning of the year when we pushed the policy. It evolved a little bit from that one, and we are planning to keep like conversation going, because even though that probably is going to be a hard conversation, I think like we need to have those conversations. Thank you very much. Mics here, there, or there.
Arturo, it's great to hear that Google's being less arrogant.
Oh, okay.
Just on obviously, there's no issue, presumably. Google's not going to require its own IXP, Transit AS. It could be LINX AS, for example, that other large providers can use as a proxy for their peer review.
Yeah. It's like if there is one of the members say, "Hey, I want to have the PNS with Google," and then you can connect me using the LINX fabric. We are fine. It's like as long as we have the relation with you, and then you are responsible wherever is behind you, that's fine. Yeah, that is not a problem.
And is Google going to commit to having network devices in popular peering locations so the cost of PNIs doesn't become exorbitant?
We are not, as I said, we are not adding any POP anymore. As soon, in the short term, whatever you see in PeeringDB is what is in PeeringDB, and it's not going to change up. It can change down, because I think that we are decommission a POP in Budapest next year. I think Lisbon is kind of do we keep it or we remove it? Prague is the same, so it's going the other direction, sadly. So we are not committing to add more. We are probably removing some of the ones that are there. Obviously, big locations like London, Amsterdam, Frankfurt, probably they will keep growing, and we are still adding capacity. We are adding a few T of like capacity with machines to receive all that connection in those places. So those are still there and gonna be there. But more, yeah, there are no more for now. Probably for cloud, yes, but it's only gonna be traffic cloud. I think that we are opening a zone in Turkey, so probably we are gonna have a edge POP there, but it's only going to be for cloud, not for YouTube.
Oh, nice to hear that Alphabet aren't pushing the costs onto everybody else. Whilst you could do all of this right now by just getting another AS number and proxying it yourself, you don't actually need IXs to do anything. You are quite right. The issue is that there aren't good enough standards of communities. There aren't well-defined BCPs across exchanges. Would you not be better, rather than re-architecting everything and going back 30 years as regards peering policies, just investing in helping build those and making the community better?
I would love if we could do that, but remember, we are a business and we have people, stakeholders, that will cost money, and they will say, no, the stock will go down and our VPs won't be happy. So most probably we are not going to do it. We think that the other way, like doing that layer 3, is not the best option. As I said, for IXs, is not the best option also for us. We will prefer giving the money to somebody else and then doing the third party. But I think that the part of trying to do that is keeping that commitment that we want something to work, not the best for you, not the best for us, but something that might work. So that will be the solution.
In which case, can you share where you can get routers cheaper than doing paperwork? Because I think we'd all like to buy loads of them.
Again?
You can clearly buy hardware cheaper than you can fill in paperwork and write standards. Can you share where you buy your hardware from?
Well, we have hardware for Arista, Juniper, and some others. But it's not only the hardware, it's the operational part of that. It's like dealing with few thousand peers. That is the problem. It's not the cost of the hardware. It's the operational burden that we have for very little benefit of traffic that is, as I said, single digits. When you go to your VPs and they say, hey, I have to add more capacity in IXs, and they say, how much cost? Well, this much. What happens if we don't do it? Well, I can use this, and that, and it will be very cheap or even free. So why are we even paying for that? And also we have the complexity operational. So it's like the business case is dead, basically. So this is kind of a keeping it alive somehow.
I'm surprised Google can't afford to run a network. Why is Google even on the internet still?
The internet, well, because we have deliver the YouTubes and the Gemini and whatever is there.
Yeah, I'm sure someone else can make a business and actually run.
Yeah, perfect. Well. It will be great. Like we have like OpenAI that they are killing us in AI, and we have to compete with them. There is Netflix and Amazon in video. There is Amazon and Microsoft in cloud computing. There is options. So we are still in business because something works, and we have to keep it working in that way.
Yeah, okay. So you franchised your network edge. Can those people charge whatever they like for access to your network? Or is there
is their business. It's like you go to ISP, whatever, and they hire, you have to pay them like 10 times whatever other competitor asking to connect to Google. Yeah, they can do that. It's their business. So.
Okay, but you're not artificially going to limit it to one per area or something?
No, okay. It's just, the only limit that we have is 10 gigs minimal and PNIs. That's the only restriction. And bear with us. And we are happy to share the cross connections.
Yeah, one last thing. Have LINX agreed to run one of these?
We have time for one more question. See at the back.
Over there, or?
To move on to the next.
Yep.
It's,
Hi, James Rice, Joint Networks Limited. In all honesty, a lot of what you said is absolutely fabulous. I fully support the whole going layer 3 edge. And I'm curious as to whether it actually goes far enough, because the two biggest quality issues that I see at exchanges today are either congestion because of rate limited ports or full ports, or neighbor expiry due to noisy broadcast domains. And if what you do is you get the internet exchange to run their own peering router on your behalf on the edge of their layer 2 LAN, then technically they're still going to suffer from all of these same problems. So why not go one stage further? It's like, if I can have a layer 3, if your ideal connection is a layer 3 connection, actually everybody's probably is. So why not just ask the IXs to go layer 3 the whole way? Then you have completely eliminate all the noisy broadcast domains. You make things more debuggable because you can trace through the IX and see what's going on, where there's packet loss or congestion or anything like that, and start saying, actually, we don't want you to do rate limited ports.
That could be a decision that the IX, instead of going to the layer 2 fabric, you do another connection to a private interconnection and PNI. You can keep the layer 2 as today we keep the layer 2 just to be there, and you can have that hybrid model, or you can just connect to the PNI. But that's a decision that the IX has to do. Like, do I keep using the switches, or do I move to a router layer 3?
What do you think would be the ideal model for IXs to maintain traffic quality?
I don't really know. I have the first time that somebody asked me that question. I don't really know, and I will hate to say this is the best ways for IXs, because I think that that's your decision. Is you as an IX to decide what to do. It's not Google for us to tell you what to do. We can tell you what you can do with us, that is this one, but it's up to you to decide exactly what to do and how to do it.
I mean,
are you joining us for the socials?
Yes.
Can I suggest that the conversation carries on there?
I have to leave.
Apologies, but we do need to move.
That's
on to the
okay.
next
Thank you very much.
presentation.
Very
Thank
happy
you
to
so
be
much.
here.